Okay, so welcome back to the Snowplow DBT web tutorial, I guess. In the first episode, we talked about how to set up a DBT project, which we called Snowplow project, and we installed Snowplow web, the Snowplow web DBT package onto that, and then had some basic configuration set up. This time, we're going to be talking more about how to customize that configuration and basically make sure that your Snowplow DBT packages work if you don't have the bog standard setup, or if you want to customize certain things, add new things, all that kind of stuff. Last time we went through the Snowplow setup in Snowflake. This time I'm gonna use BigQuery just to do something different, but nothing really changes from an end user perspective, which is quite nice. So it doesn't really matter whether you're following along with BigQuery or Snowflake, Databricks, Redshift, Postgres, whatever. It should all be pretty similar. Okay, cool. So let's start. So first of all, we kind of assumed that your Snowplow data would land in an atomic schema. So your raw data, would land in an atomic schema with the event table name. But what if it doesn't land in a schema called atomic? You can use the snowplow _atomic_schema variable. Basically, you can use that to tell the DBT package where your Snowplow data is actually landing, so in which schema. So if we had just the Snowplow schema, for example, this would be the case if your data was landing in snowplow.events, right? If it's something else, then cool. You can change this. This doesn't affect where your derived and scratch data is going to land, but instead only affects where your source data is. So actually, on that note, if you don't, for whatever reason, which is completely fine, if you don't want your scratch and derived data to land in the scratch and derived schemas, which we set up last time, that's completely fine. You can just set that up here under the models configuration. So under models, we'll say for Snowplow web, and then we'll start with, let's say, the page views module. And so by default, the page views, we want the schemas to be maybe Snowplow derived instead. So maybe you already have a derived schema and you want to have your Snowplow data sit separately from your normal data. That's completely fine. And then for all the scratch stuff, we will put the same thing, but then we'll just do Snowplow scratch. That's fine. Yeah, you can do the same thing for sessions, right? So you can just set it up like this, Snowplow derived, and then in your scratch, you'll add the schema Snowplow scratch. Great, and you can do the same for users. You can do the same for all the other sub modules, basically. A quick way to see what models you have and what the directory structure is again going to DBT packages, Snowplow web models, and then basically you can go through these, right? So we didn't add base, but I mean, if you want, we can add that as well. Everything in the base module should just go under Snowplow scratch, so that's fine. And then, yeah, we have user mapping and we have users. So again, just following the structure of the directory, you can change, you can set custom schemas if you want, and the DBT will adhere to that. Basically, if nothing is provided, DBT will stick to the defaults provided in the package. But if you overwrite those, and we do that by specifying that for the models in the Snowplow web package, we want to set, for example, the schema attribute to be Snowplow scratch, in the base, Snowplow derived in the page views, but then more specifically Snowplow scratch in the scratch page views, etc., etc. So you can do all that, and then DBT will understand that and take care of that. Cool. So that's choosing a new schema for the data to land in. This is choosing a new schema for the data to arrive in. Then we also get some questions about like how would you actually end up extending the DBT packages to include your own things. So we have some examples that we've written up that you can find in GitHub, that you can find inside your DBT packages, Snowplow web, and then the custom example directory. but we'll also walk through them here. So we have two examples. So one will be walking through how we can modify the page views, and another will be how we can modify sessions. So let's say we wanted to modify the page views. We don't actually have to put this in a BigQuery folder, so we can remove that BigQuery folder. So what we've done is we've created inside your models folder in your main Snowplow project directory, we've created snowplow_web_custom_modules folder. This makes sense because you might have your, my company reports, or I guess it would be more aptly named my company models folder, where you would have your own, where you could have your own DBT modeling and DBT transformations being done. And then if you want to kind of separate out the two, then you can do that by just applying this this folder structure. Inside the Snowplow Web custom modules, we have a page views folder, which in turn has a page view channel engagement. And if we look, we created a model called snowplow_web_pv page view _channel_engagement.sql. And what that looks like is something like this. And basically what we have is we're referencing the Snowplow Web base event this run, and we're doing some custom logic to look at some link clicks, basically. So what we talked about, what we might have talked about before, is the incremental logic of the Snowplow Web package and the various Snowplow packages. Okay, so what we talked about before is basically we have the Snowplow Web base model inside the Snowplow Web package, and we'll have the same for mobile. And that handles a lot of the incremental logic. So inside Snowplow Web base events this run, that takes all the events you might need for this run. So all the events that still need to be processed given the various parameters set in here, as well as the current state of your data. So what has been updated the latest. And it extracts all the events, all the related events that you might need to process whatever it is that you want. So the reason why we put that into its own table, and it's its own scratch table that gets dropped and recomputed with every run, is so that you can end up leveraging that if you want to create your own custom modifications to the kind of workflow of the web package. So in this example, we're referencing the Snowplow Web base events this run to get all of the base events this run. We're picking the distinct page view IDs, so we're getting one row per page view ID, and we're counting how many event IDs there were for all the link click events that there were, because we're filtering here, which we'll get into in a sec. So we're counting on this page view how many links were clicked, and then we're doing the same but with first value to see what was the actual target URL of the first link click, so the first link target. So what we're doing is we're getting all the base events this run, and we're making sure we're filtering out only those where someone actually clicked a link, which we do with this context of the Snowplow link click. Then whenever we're looking at incremental data, we need to make sure when we use Snowplow incremental that we have this snowplow utils.isRun with new events with the argument Snowplow Web. This is something that we do include in all of our incremental models, and this basically ensures that if there's no new events to be processed, this won't run and this won't do anything weird with your already existing incremental data. So we're creating the CTE of link clicks, which does what we described. So a new line, so one line per page view ID, and then what was the number of link clicks and what was the first kind of link or the target URL of the first link clicked. You could add the same of the last value, or you could add whatever you want, basically. And then we're also looking at the actual page views this run. So now we're getting more context around the page views, and we're looking at we're trying to proxy engagement. So we're selecting from the page views this run, the actual ID, when that page view started, whether that user came on to us via search, and whether it was paid search, CPC, PPC, SEM. We're going to basically qualify that as paid search. If they came via Google Ads or whatever else, or Google Ads services, all that stuff. We're basically just classifying the channel through which users found our website. And then we're checking whether on this page view, their engage time was actually positive or not. If it was 0, then we're saying this person ended up bouncing from the page view. If it was not, then we're saying they didn't end up bouncing from the page view, so they spent some meaningful time on our page. And we're also checking what percentage of the vertically of the page they've scrolled, as well as, so we're weighting how much they've scrolled along the page, as well as how much time they've spent engaged on the page. We're weighting that with 70% weight on the engagement time, and then 30% weight on the vertical percentage scrolled to get some sort of engagement score. And so what we're going to end up with is a page view ID, when that page view started, where that user came from, or so where that page view came from, I guess, whether that page view ended up bouncing, and then what their arbitrary engagement score was, which we've just defined here in a relatively arbitrary way. So those are our two CTEs. And basically what we're going to do is we're going to join the two of them so that we have a page view ID, we have a start timestamp, we have what links, how many links they clicked, and what was the first link they clicked, whether they bounced, what their engagement score is, and what channel they came from. And we've built this as a Snowplow incremental table. So again, we're taking advantage of the incremental framework. So if you have billions of events per day, you should still be able to see this be processed in a relatively optimized way. And you don't have to worry about making sure that you have the latest data and how the incremental logic works, because you've materialized this as a Snowplow incremental table, as well as referencing kind of the base events this run and the page views this run. So any table with this _run, you should reference with incremental logic. And then wherever you use the materialization of Snowplow incremental, it's a good idea to use this util is run with new events to ensure that, yes, when this will only actually execute when there are new events to be processed. So this is just an example of what you can do to create an incremental table that has some custom attributes. You don't necessarily have to use these. I mean, these were picked relatively arbitrarily, but this gives you an idea kind of how to play around with some of the Snowplow data. So once we built this Snowplow web page view channel engagement table, which will be a table which will end up in our, well, we haven't specified actually where it will end up, but we can specify that in a sec, but will likely end up in our derived schema. We can then also create a new page views table, which is called Snowplow Web Page Views Custom, which uses the already existing derived Snowplow Web Page Views table. And we can join that on the just now created Snowplow Web Page View Channel Engagement table. We can just join them on page view ID to page view ID because they're one-to-one mapping. And then we take everything from the actual already existing derived page views table, and we just add the 5 new fields that we've just calculated, which should be completely fine. We'll materialize this as a view, but you can materialize this as a table if you want, or whatever you want. It doesn't really matter. Inside here, we can also define the schema itself. So we can call this Snowplow derived. Oops, derived again. But we don't have to. But yeah, we can define that here, and we can also define that in the actual dbt-project.yaml, which we can do in a second. So that's kind of how we build new derived tables. And if you wanted to create this as a drop and recompute and then join these together, cool, you could do that as well without. So then you would materialize this either as a table or as a view, and then you wouldn't need to use this macro to filter out when Snowplow utils run with new events. Great. So then, similarly, we can do something with sessions, and in sessions we can create, like I said before, we can create a simple drop and recompute, where we look at, in this case, the page views this run again. So again, we're only processing the data that we actually need to process. We're selecting a domain session ID, grouping by it so we'll only get the distinct ones, and we're gonna check for each session ID whether there was a page view with a page URL path of or something similar as mysite.com/product or mysite.com/order complete. And then we'll say if they went on products, then we'll say that this is a session with intent. If they went on order complete, then we'll say that this is a session with conversion. And this gives us an idea of how to check whether users converted or intended to convert in that session. Obviously, for your flow, conversion might look very different, and this might be in a custom context. So you can check whether values in a certain custom context were true or false or whatever you need, or you can look at whether someone ended up on a certain page in their session. But yeah, this is very simple. I mean, classic. Nothing Snowplowy about it, except that we're again referencing a this run table. Then we have this Snowplow web sessions custom.sql. And here again, we're materializing as a Snowplow incremental model. We're doing some partition by, unique key, upsert date key. And we're going to be selecting, again, everything from the actual Snowplow web sessions this run, which we're going to alias as S. So we're again looking at this run. We're going to be joining on the Snowplow web sessions conversion this run. So notice we're sticking to the same convention in our custom modules of if something is just going to be a drop and recompute, we're going to call it a this run. And again, also because it's only processing data from this run. So we join those two, we get everything from the sessions this run, we get everything from the web sessions conversion this run. We're joining on domain session ID, and again, because we're running this Snowplow incremental model, we're going to say where Snowplow utils is run with new events for the Snowplow web model. So the idea behind this is that it stops us from having to need the actual Snowplow web sessions table, which is great. So what we can do once we've set this all up and once we're happy with everything is in our dbt project.yaml, we can go back to our models. We can go in Snowplow web, we can go to sessions. We've done all the schema stuff. And then we can say Snowplow web sessions enabled is false. So that means that the Snowplow web sessions inside Snowplow web will no longer actually be run. And then one thing we have to do is, so we need the sessions table later to generate some data on users and to do our aggregations on users. And so if you want to do that, what we've done is we've created this Snowplow _sessions_table variable, which you can use to reference now your custom table that we've just created, instead of referencing the original one, which has now been disabled. So you can do that for sessions, and then your users table will instead use the data that is in your custom sessions table instead of the standard sessions table, which is no longer being updated. Okay, so one thing we still need to do is we need to customize the schemas. So we're doing that for models inside this project called Snowplow project. Then we're going Snowplow web custom modules. Sorry, let's get everything together here. Yeah, then we can set the default schema basically to Snowplow derived, since most things are Snowplow derived. And then and we can also set the tags to be Snowplow web incremental. And then for specifically the session conversion, we can set the schema to be Snowplow scratch, since that's going to be a scratch table that we drop in. Okay, so now that we've done that, let's just run it. So in our case, we'll have the data in a pipeline, in an atomic schema called RT pipeline dev1, and we can dbt run this project, and then we'll run all the models in this project. We've saved everything. Yes. So let's see. So now we have 23 models instead of the standard, 20, because we've added 4, but we've disabled 1. So that should give us 23, which is correct. There's no data in the manifest. Fine. Yeah, so now we should just be processing all this data. So let's make sure this runs properly. And then if it does, then we're all good to go and keep exploring and keep building new custom modules that expand kind of the functionality that you want out of the web package. And remember, everything we did today, the exact same things can be applied to the mobile package or to the media player package. So it's all built in the same way with the same frameworks, just slightly different internal logic of how we deal with sessionization, page views, screen views, engagement, all those kinds of things. But the general idea is all very much the same. Cool. So that's all managed to run successfully. We've skipped through kind of the actual run of this because it takes a little bit of time. But one thing we can see is we've created a model called Snowplow Web Sessions Custom, which is in the Snowplow_derived schema. Like we said, everything else is in the... Oh yeah. Okay, cool. This is good because then we can see that this actually works. So in Snowplow Web, in base schema, we set it all to be Snowplow_scratch, which we're seeing here. We did the same for page views and same for sessions, where we set some stuff to derived and some stuff to scratch. You'll notice we didn't do it for users. So you can see that for users tables like Snowplow Web users ags, it's just in scratch. And then for Snowplow Web users, it's just in derived. So that just goes to show that everything works as expected. Yeah, so we can see our web sessions custom table here, and we can see that there's no actual web sessions table being created. However, well, because we disabled that. However, we have the web page views custom table, which is created here, and also the web page views. And that's because we didn't disable the web page views table. It also wouldn't have made sense in the way that we defined everything, but that's just interesting to see how that all works. So hopefully that gives you an idea. Again, you can find these examples that we walked through in your, once you've run dbt deps, you can find it in your dbt packages, Snowplow Web, custom example, and then under the models folder. And even in the dbt project.yaml, we have some, we have this config as well set up and the changes you'll need to make in the sessions table. We also have a README that kind of talks you through how this all works. But hopefully, yeah, either this video or that README helps you kind of understand what's going on and what the underlying logic is, and hopefully you can build your own custom stuff on top of this. As always, if you have any questions, head to our discourse or ask in the comments or send us an email or whatever. We'll figure it out and we'll try our best to help you. But hopefully this has added some value to your Snowplow dbt projects. And yeah, see you again in part 3. Thanks.